Welcome to CAD Academy. So this tutorial is about die design and all its manufacturing process, extracting the NC code from catia and simulating it in ansys. So we can see that how that sheet metal deforms from that die, and what will be the working of that die. We will see that in ansys, and we will easily extract some NC codes from catia and install it to CNC machines so that we can manufacture that die. So let's start and make a product. I am making a door handle, as programming in ansys to some complex product gets hard and take long time. So I am just making a door handle as it is easy. So let's first make a profile, and I will sweep again on that. Okay, now just give it a 50 dimensions. Let it be some 50, 20. I am giving roughly. Don't assume that the handle has this dimension. And let it be 65, I think so. Okay. Now, okay, sorry. Mirror this. Okay, now exit that, and just insert a plane normal to this profile at some point. I am inserting at this point, and sketch on that a profile which you have to sweep. Okay, just zoom it a little bit. Okay, now I am making a center rectangle. Okay, this is our center rectangle. Just give dimensions. Let this be 10 or 15. Okay, the thickness must be minimum, so that sheet must be deformed to that sheet, and thickness must be such that it must also accept the strength what we are giving to it while for pushing the door. So I am giving the thickness as 1, and I am using aluminium as we will do analysis. Aluminium has some ductility property, and it will deform to that easily. Rather than taking stainless, I could have been taking stainless steel, but my CPU is not enough stronger to do that much of amount of analysis. So I am going for this. Just give some fillet here. Let it be 15. Okay, and also give some fillet here. That will also 15. Sorry, 15. Okay. Now give fillet here. Let this be 10. Also give fillet here, and let this be 10. Okay, so our profile is ready. Just sweep this too. Sorry, cancel this. Select the profile you want to sketch. So you can see the door handle. Okay, let's do some modification in that. I'm again opening the sketch. Okay, now insert some point at distance of say 5 mm. Okay, mirror that point. I am giving a curvature to that profile by taking point as reference, and insert a point here also. Again insert a point below this point. Okay, now let's take the curvature command, or what we say that, and give a radius. I am keeping parallel to this so that your sheet must be deformed properly. Actually, this is a strip which will be deformed. Now strip this. Okay, so this is our swept profile. Now we need to make die of this. So for that, go to shapes and then generative shape design. Okay, now here you will get a command of extract, multiple extract. Just click this and select all these surfaces below, the below ones. Take the side surface also. Okay, that's it. Oh sorry, side surface also. Okay, preview. Now you can see surface has been made. Now I am taking this sketch, selecting that, and I will be drawing. Sorry, I will be projecting the outer line. Okay, just click on project. That's it. Now draw a line from this point to this point and exit. Fill this and mirror this. So this is translate. Click on mirror, symmetry. I want to symmetry this object around this plane. And this is what we have made. Now again click on this surface, click on sketch toolbar. Now you need to project this boundaries. Okay, exit this and extrude till some limit. Extrude to whatever length you want, doesn't matter. This is just used. This will be just used for trimming solid. What we have to make a die. Okay, now you can see. Now save. Sorry. Join all these sketches. Click on join. Select all the sketch, symmetry, then extrude, then multiple extract. Okay, now you can see all this joint. Now let's make another surface for tool which will be bracing. So select multiple extract again and select this outer surface of the part. Okay. So this has been selected. I'm just hiding this so that we don't get confused. So this is our part, and we will make a tool of that. I am saving this file, just making new. Okay, let ms express it. Let it be water. Okay. Now minimize this. Open assembly design and insert your part here. Okay. Let me show that symmetry also. Oh, sorry, join also. So this is our part. Just go to product, insert a new part, go to part body and go to start and then mechanical design, part design, and extrude this. Sorry, for that go on sketch, take a plane and just select the outer boundaries of this. Sorry. I will be projecting that so that I can extrude. Press Ctrl and then select all, so that will select all of these edges. Now pad this. Pad below also by somewhat length, so that your die gets some strength. And then click on this fade command. Now clicking on this command, just click join. Okay, and press OK. So you can see this is our die. Our die has been made. Now make a let's make that tool. Again insert a part. Part body. Now select the surface and project that. Project these boundaries. Okay, click on project. Okay, now exit this and add downwards also by whatever length you want. Doesn't matter, it will be split. Click on the split command and then select your multiple extract here and reverse the direction. Now you can see that our tool has been made. Okay, I am hiding this, so you can see our tool has been made. Let's see some section view. So you can see section view. Now let's see some machining process of this process. Before that, save the model file and then save the product by some name or what you want. Let it be product. Okay, now I'm cutting this and I'm also cutting this, and then file, open, here product XYZ and then part 1. We will see some machining operations of this part, how to extract that NC codes from catia. So go to advanced machining, Okay, now click on part operation. Double click on part operation. You can see where tool is positioned here. So it is 100 mm above from this reference axis. So I am changing this reference axis. Click on this axis tool or what we say, don't know. Click on that dot and place it here. So your axis will be here and your tool is 100 mm apart from this. So before that, let me make a body, stock body, so that that stock body will be animated, and then cut it to this die part. Select z-axis and let this be 50. Okay. Now this body will be cutted and will be produced as die body. So properties and to graphics, increase the transparency and also give color to it so that it doesn't confuse you. Now go to start mechanical and machining and then advanced machining. And then double click on part operation. This is our 100 mm apart tool. Keeping the axis here. Okay. Now body, select the body which has to be which is being machined. Hence the final product what will be looking like, and then select the body which has to be machined. Select a safety plane. This will be our safety plane upper plane. Okay. So now insert a tool here by going to insert tool, auxiliary, operation and tool change, and then we will do end milling. Minimize this manufacturing operation, and I am reducing this diameter of the tool by 2 mm and radius by 0. I don't want radius, or what you have in CNC you can use that by giving that dimension. Now insert machining operation and go to surface and then roughing. Okay, now select your part body, the body which is being machined, which has been machined, or which will be, means the die part. Select the body which has to be machined. Select your safety planes, the above plane. Select the bottom plane, the lower plane. Okay, we can change the type to what we want, zigzag, spiral. I am giving you helical and the tolerance of 0.1 of preview. Okay, this is that roughly open. Parameters are okay. Just see the tool path. Model, let's animate this. So go to, so you can see this is our machining operation. Okay, so now we have to finish. This is all this roughing operation. We have to do finishing. So I am inserting a tool again and end mill to manufacture, and then keeping its diameter approximately, let be 2 mm. And radius of 1 mm is okay, I think so. Or let this be 1 mm and radius be 0.5 mm, it's okay. Now insert and then go to machining operation and surface machining, and then isoparametric machining, and select all this curvature part. Just click on this and select all these curvature parts. Click on OK. and select these points. This point are here. Click on 1, 2 and 3. Okay. Sorry. 1, 2, 3, 4. Not selected again. So, 1, 2, 3. What is happening, bro? Okay, and then next screen, go to machining, surface machining, and then isoperimetric. Select this tool change, and now select this. Now our tool will be going from here, here, and we will selecting like this. Now from here, return, and then returning from, sorry, this. We need to select this sequence wise. Sorted out that issue, and then select here starting points. And your ending points are this. Okay, that's a great thing. You can see it's doing zigzag. Okay, now let's review all this process and see what the product we get. So go to this tool 2, go to isometric this right click this and go to rotate tool path. Select this video and then let's do machining. But this is machining of just that part. We need to start producing mission run. Let me see. Okay, now we will be seeing that toolbar. So go to this and then click on rotate toolbar. What has been done by this is that first it has done the finishing operation and then cutting, but no problem, as it's just a video sortation. It has first done this and now doing this. Let's start with the machining operation. I have already created a body here. I have just extruded this surface and created a body which has to be machined. Now let's go to this machining operation. Select advanced machining here, and now I will be directly doing the smoothing operation. For that, before that, just arrange this new setup. This is our axis where it will be placed here, and from this axis our tool is 100 mm apart, which you can change the value here. Okay, now select the die part and now select the stock part which has to be cut in. Select a safety plane here and that's it. Now I am going to insert a tool which will be end mill, this manufacturing program, and just giving it a diameter of 1 mm. Now select. I'm going to insert parametric machining here. Now, before that, add this body. Sorry. Okay, select this, and now select this a sequence-wise manner. I am going as a spiral. But select all this profile in continuation. Okay, so part has been selected. Now click on these dots, select this, then this. Okay, sorry, select this and this. This not taking again. Select this and 2 and then 3 and then 4. No? So I think I forgot to tell about that extracting ANSI code. So for extracting ANSI code, you can click here or generate ANSI patch, and then ANSI code and save your file value. So that will extract ANSI code. Okay. Now I will do analysis of this. So before that, we need to save this file as a save file. Open this product and wait a minute. What is the distance between this and this? Let me see that first. This is 1 mm, okay? And offset this product. Sorry. From here to here. This is 20. I will be keeping it as 70. I think that's far away. Keep it as 40. And we do this. Okay, that's okay. Now insert a part here as a metal strip, which has to be on which operation has to be done. It is of 1 mm, as we have seen it. This row. Click on section view. Just insert or project this profile. Project this or let it give that. Take center rectangle. Okay. Now give a length here. This must be, let this be 12.5. 15.5. This will not touch this, or the friction will be created there. So I am keeping this as 13.5 and the length as 300. Okay, I exit this and extrude this by 1 mm or 0.5 mm, what the thickness you want to strip. Okay, I am keeping it as 1 mm. In reverse direction is wait a minute, I need mirror extend 0.5. No, we cancel that. I think we have selected wrong thing. Just delete this and select this plane, select all this, and project it on that plane and exit. Now add by 1 mm, preview and reverse direction, preview, no, reverse direction, preview. Okay. So this is our die and our tool. Now we will save this whole product. Double click on product and save the whole product. Save as it as a step file, renaming it by some 1, 2, 3, 4, 5, 6. Okay, save. Okay, now open the ansys. Okay, so I have opened ansys. Now extract the split or drag this explicit dynamics here. Double click on engineering data, and now click on this engineering data sources. Select here general materials and then here aluminum alloy. Click plus icon here, and this will be added in our list. Now insert our geometry by right clicking on geometry, import geometry, and then browse, and then select our file 1, 2, 3, 4, 5, 6, and then double click on model. Okay. Now let's change the material of this to aluminium. Now we need to assign some connections. So this is our connection. What we can see that this connection is wrong. This strip is connected to this side boundary of die. This is wrong connection because we have given some tolerance to this. So I am deleting this connection and inserting a frictionless connection. Now select this, and for frictionless connection you need to select this one. Okay, so our frictionless connection has been assigned. Now let's go to mesh, and I am inserting a sizing here so that my solution gets as early as possible. If you want an exact solution, so you can decrease this size value, but I want fastest result, so I will be increasing this value. I'm selecting this both element because their size doesn't matter. Keeping it as 20 and then generate mesh. Okay, you can give size to this, but I want a fastest solution. So with the time as 0.003, insert here public support, and for that add this body, add this body, go to click support and select all the things. Okay, all the faces have been selected and all the faces have been fixed, as that part of die will be fixed to the ground. Now displacement, before that show this body. Okay, and then click on displacement. This is 40 mm apart, and this is wait a minute. Okay, that is 40 mm apart. Now select this face and it gets confusing while using catia and ansys both. And now this die will be going downward by 39 mm and 1 mm sheet will be present here. Okay, so minus 39 will be our displacement. Now let's solve this. Don't know. Product also not. Okay, solution has been done. Let's see how this deformation looks. So click on evaluate result and let's show this body first. Click on this deformation. You can see our tool is not withstanding this. Wait a minute. This tool is going very much downward, but wait a minute. Let's see what is distance between this part and this part. It's 21 mm. So 2 must move 20 mm. So click on displacement and this is 20 mm. So okay, so operation has been completed, and this still our plate is being leaking. Means this operation is not possible. You need to select a much higher strength material for this. Structural steel is not enough material for this die. You can select a much higher steel material. This I am seeing what plate forms. Okay guys, so this is all the process of sheet metal die preparation. You need to apply all this physics and all that so that this die can be properly prepared. In our syllabus there is a production in GATE syllabus. From there you can see all this thickness related issues and all this what you have to keep. I just made this tutorial for learning purpose of die. I have not calculated all this thickness or this, just I have made this tutorial for die making process. So if you like the video, please like it and subscribe.